Okay, everyone, so now we're going to be solving exponential inequalities, which you solve them in the same way that we just solved exponential equations. So the first goal is to try to get the same base on both sides, and if you can do that, if you have the same base on both sides, so if b to the y is greater than b to the x, then you can just drop the exponents down as well as your inequality symbol. So y would be greater than x. So the first thing, you always try to get the same base on both sides. Now, if you cannot, like in our second set of example problems, you must convert that into a logarithm if you cannot get the same base on both sides. Now, something we need to keep in mind while we solve. Whichever way your inequality is facing toward your variable, okay, it must always face that direction. Always. Okay, so even if your variable switches sides, the inequality must be facing the same direction as it is in relation to the exponent. So for example, since my variable's on this side, since my inequality is facing away from my exponent, it's not facing toward it, it's facing away. Okay, since it's facing away, if this variable for some reason moves onto the other side of my inequality, that inequality must still face away from it. So we just have to keep that in mind, which it'll probably make more sense when we solve. So if that didn't make sense at all, don't fret, we will clear it up in just a moment. Okay guys, so the first thing is to try to get the same base on both sides, which I'm just going to focus on the 27. I know it's a fraction, but we can deal with the fraction in just a moment. Okay, so the first thing I need to do is try to think of a number that both goes into 3 and 27, and I can raise to an exponent to get those numbers. Okay, so let's think about this. Holy hot dog, you guys are so smart. It is 3. You guys already knew. Okay, because 3 to the first power will give me 3. And 3 times 3 is 9, times 3 is 27. So 3 to the third will give me 27. So we are going to be using 3. Okay, so I'm going to keep my base. I'm going to leave it alone. And my goal is to get a 3 on both sides in my bases. Okay, I'm going to bring down my x minus 4 as my exponent because it's still an exponent. We can't forget about it. Okay, and I'm still going to remember that my 27 is in the denominator. So I'm going to put 1 over 3, and we're going to raise it to an exponent in just a moment. Okay, you guys, so I need to think about an exponent that I can raise to get 3 from the base of 3. Well, guess what? 3 to the first power is 3, so my exponent is just going to be 1. And sorry, guys, this should be x minus 4, not x minus 1. My bad. Sorry guys, the demon cuts got me for a second. Okay, and then on this side, I need to think about what power of 3 goes to 27. Which way I went through it, 3 times 3 is 9, times 3 is 27. So, 27 is same as 3 to the third. Okay, which remember you guys, when you have an exponent beside an exponent, you just multiply them together. But 1 times anything is itself. So 1 times x minus 4 is x minus 4. So this is going to be 3 to the x minus 4 is less than 1 over 3 to the third. Now, I cannot work with this 3 when it's in the denominator. So we're going to have to move this bad boy to the numerator, which, if you remember when we did that, the way we do that is by changing our exponent to the opposite sign. So since this is a positive 3, when we move it up, that 3 will turn into a negative 3. Okay, so when it shifts up, you just change the sign of the exponent. Alright, so do you guys see it? We now have the same base on both sides. Holy hot dog. So, since we have the same base on both sides, I can drop everything down. We're going to drop our exponents down as well as our inequality symbol. So we're going to drop down the x minus 4, the symbol, and the negative 3. So this will be x minus 4. So that drop down is less than, I'm going to drop my symbol down, negative 3. Okay, so I just drop my exponents down as well as my symbol. Okay, so we're going to keep solving, you guys. I'm going to bring this bad boy up here so it doesn't get mixed in with our next example problem. So we currently have x minus 4 is less than negative 3. Okay, so let's keep solving. So now I must isolate my variable. Okay, so I need to move my negative 4 to the other side, which the way we move that to the other side, the opposite of a negative 4 is a positive 4. So we're going to add 4 on both sides. Okay, so negative 4 plus 4 will cancel and turn to 0. So I'm going to be left with x, bring down my symbol, is less than negative 3 plus 4 gives me a 1. And that would be my answer, you guys. So x is less than 1. Pretty nifty, right? Okay, so let's keep going. On to example 8. Okay, so example 8 is actually really similar to the one we just did. So if example 7 made sense, you can go ahead and tackle example 8. Now, example 9 though is different. Okay, so I probably wouldn't go all the way to example 9 yet unless you wanted to try it. Okay, but example 8 is pretty much like this one. So let's get going on this one. Okay, yes, so the first step when we solve exponentials is to try to get the same base on both sides. Okay, so currently I have a 10 and a 100, so I need to think about a number that will go into 10 and 100, and also I can raise to an exponent and get 10 and 100. Okay, now there's several things you guys are probably thinking about. You're like, probably, 2 would work. 2 will go into 10 and 100. Okay, let's think about this. Can I raise 2 to a power to get 10 or 100? So 2 times 2 is 4, times 2 is 8, times 2 is 16. Holy hot dog, we just skipped over 10. So 2 is not going to work. Okay, you're probably like, okay, Miss Long, well, 5 also goes into 10 and 100. So let's see if that will work. 5 times 5 is 25. Oh no, that definitely isn't 10. So 5 is out of the question, but the next number that will go into 10 and 100 is 10. Okay, 10 to the first will give me a 10. And 10, let's see here, 10 times 10 is 100. So I can raise 10 to the second power and get 100. So we're going to be using 10 as our common base. So since 10 is already over here, I don't really need to do anything because we already have it as base 10. Okay, so I'm just going to bring down this first part. We have 10 to the 4x plus 1. I'm going to bring down my inequality. Is greater than or equal to. Now I'm going to rewrite 100 using base 10. So let's see here. 10, we said 10 times 10 is 100, so it'd be 10 squared. Okay, which I don't have any exponents to combine. We don't have exponents next to exponents, okay? So now that we have the same base on both sides, we have a 10 on both sides. Now we can drop down our exponents as well as our inequality. So I will currently have 4x plus 1 is greater than or equal to 2. And from here, you guys, we just solve for x. Okay, so I'm going to go ahead and bring this up here because I know I'm going to run out of room because I write big. Sorry, guys. All right, so we have 4x plus 1 is greater than or equal to 2. All right, guys, let's get going. So I must get x on one side by itself. The way that we move this 1 to the other side, you already guessed it, you got to subtract 1. The opposite of positive 1 is negative 1. 1 minus 1 is 0, so those bad boys cancel out. And 2 minus 1 is 1. So currently, I'm left with 4x is greater than or equal to 1. Alright, and from here, we're going to get x by itself, which, secretly, the 4 is multiplying to the x. So the way that we move 4 to the other side is through division. So this would be x is greater than or equal to 1/4 as my final answer. And that's it, you guys. Not so bad, right? Not so bad. Awesome. Okay, so in our first 2 example problems we've done here, example 7 and 8, okay, we could solve the inequality like we just did, and we could get the same base on both sides each time. Okay, but sometimes that doesn't always work out. So in example problem 9, we will not be able to get the same base on both sides. So we will talk about how to deal with that. Okay, because if we think about it, okay, we have 2 to the x plus 1 is less than 7. If you think about it, if I want to find a number that goes into 2 and 7, well, the only thing that goes into 2 and 7 is 1. And no matter how many times I raise 1 to a power, you're going to get 1. 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. So that will not work. Okay, so nothing other than 1 goes into 2 and 7. So if you remember from our previous problems, when we could not get the same base on both sides, that's when we had to follow these nifty steps, if you remember. We had to get the exponential by itself, convert it to a logarithm, and solve for x. So we will be following those same steps when we solve this problem. So the first step, we must get our exponential by itself. Holy hot dog, it's already by itself. Nothing is added or subtracted to my base. Okay, the exponent is x plus 1, but that one is not added to the base. It is added to my exponent. So the next step is to convert this to a logarithm. Now, this is when this thing I warned you about is going to come into play. Currently, okay, the inequality is facing away from my variable. Okay, it's currently facing away. So if that variable moves to the other side, it must still face away from my variable, that inequality. Okay, so we have to be careful. Our inequality faces the same way it always faces. Okay, so when we convert this bad boy into a log, okay, the log always stays on the same side as the base. Okay, so the base is currently on the left-hand side of my inequality, so my log is going to stay on the left-hand side of my inequality. Okay, so like normal, the base of the log is the base of my exponential. Okay, which the base of my exponential is a nifty 2. Okay, and then these two are going to trade places, flip to the other side of the inequality. So my 7 is going to hop on the inside of the log, and my x plus 1 is now going to hop to the other side of the inequality. So, since my x plus 1 is currently on the left-hand side of my inequality and it's facing away, so it's left and it's facing away. Now that it's on the right-hand side, it's still, my inequality has to be facing away. Okay, which if I drew it the way it's currently facing, this would be opening up toward my x plus 1. Okay, I want it to be facing away though, so my inequality is going to flip. Okay, do you guys see what happened? My inequality is still facing away from my x plus 1. Okay, it was facing away from my x plus 1 here, and it still is facing away. So, you must keep that in mind. It's very important. Okay, if you ever trade sides of an inequality and there's a variable in the mix, that inequality must face the same direction as it faces the x, always. Okay, so when we're solving, okay, we must get x by itself. And then we'll be done, because that was our last step. The last step said to solve for x. So we converted it to an exponential, or I'm sorry, to a logarithm. And now we're going to solve for x. Okay, so I need to get x by itself, which currently that 1 is in the way. So I need to move it over. Okay, so I'm going to be subtracting 1 on both sides. Okay, which I'm going to just tack it on to the end over here, and I'll explain why in a moment. Okay, 1 minus 1 will give me a 0. Okay, so I'm left with x is less than log base 2 of 7 minus 1. Okay, now that x is by itself, okay, technically this is our answer. But you know Miss Long, she likes the x to be on the left-hand side. So technically, if you want to stop here, you can. You could circle this bad boy and this would be your answer. Okay, but the x irks me when it's not on the left-hand side, so I'm going to show you how I would write it. You don't have to write it this way. Okay, but this is how I would write it. So I'd write my x first. Okay, so I'm going to have x. Now, my inequality still must be facing the same way it was facing here. So since my inequality is facing away from my x, it still has to face away on this side. So it's going to kind of flip again, because I like my x to be on the left-hand side. And then I'm just going to write all that next to it. So we have log base 2 of 7 minus 1. So this would also be an acceptable answer. Okay, if it does not irk you when x is not on the left-hand side, you can leave it like that though. But either of those are correct. Awesome job, you guys. I've had so much fun with these.